Okay, so now I want to get into deriving this rule, but first, let's talk about, before we derive it, let's talk about whether this is intuitively true, whether it feels true given the semantics that we've associated to the quantifiers. So how about trying to express these in English without mentioning any quantified variables? So you have some homework exercise where you need to do this a bunch of times. So this will kind of help you a little bit with that exercise. So I've got, there exists x such that for all y, y loves x. And my goal is to just interpret this, get the meaning of this, by rewriting it in English without mentioning any of the quantified variables. So what I would suggest is working from the inside and working your way out. So start with this. So this thing, let's make it blue. This one says, for all y, y loves x. In other words, everything loves x. Everything loves x. Right, so you can say this without mentioning the y. The y is just a placeholder to help you say that everything loves x. And our overall statement becomes this. There exists an x such that everything loves x. So how would you describe this in English? So you could say everything loves something. You could say that. But that's a little bit ambiguous. Is this saying there's this one something and everybody loves that one thing? Or is it saying that given any thing, it loves something? You know, these arrows represent loving something and the dots are the things. So which one is it saying? Is it that there's a universally loved thing, that everyone loves that something? Or is it saying, you know, everybody has something that they love. It doesn't have to be the same thing for everyone, but everyone has at least one thing that they love. So you see that it's ambiguous, right? And that ambiguity is actually exactly what these two propositions in our derived rule are capturing. Both of these you could actually end up writing as everything loves something. But they have different meanings. And that is evidenced by the fact that you have one arrow here, but you are not going to get the arrow going the other way. So you only get a one-way implication. And, of course, yeah, these feel pretty different, right? Having one universally loved thing versus not. So let's find a better way to write this that's less ambiguous. There exists an x such that everything loves x. So this is saying that there's an x that's universally loved. Everything loves that x, that particular x. So how might I say that in English? Maybe there's something which is loved by everything. And how about the other way around? If I say for all y, there exists x. So just swap the quantifiers such that y loves x. Then again, work from the inside out. So this part says there exists x such that y loves x. So in other words, y loves something. So overall, we've got for all y, y loves something. Now that's the other interpretation of everything loves something. For any given thing, y loves something. Now, how might I express that in English in a non-ambiguous way? How about everything has something that they love. All right, so going back to here, our derived rule that we're going to try to establish here is going to be, how to say this, if there is something which is loved by everything, then everything has something that they love. So hopefully that sounds intuitively true. If there's something that is loved by everything, then indeed everything has something that they love, namely that something that is loved by everything. Sometimes this kind of statement here is referred to as a global existence. There is something which is loved by everything. So there's one X that globally works for making this proposition true. It works for all Y. Where on the other hand, this kind of statement could be referred to as local existence. There exists an X that makes such that Y loves X, but it's not the same X that works globally for all Y. It's a local existence. X only works for each. There's an X for each Y, but the X's could be different for different Ys. Okay, so these kinds of subtleties are part of the reason that the rules for quantifiers are so complicated. The last time, in the last videos from the previous lecture, they're so involved to explain exactly the subtleties there. It's because of things like this. So, okay, let's start the actually important part of this video now, which is deriving the rule. So, deriving this implication. And what might actually be more important is not than deriving this implication is afterwards looking at how we cannot derive the other implication. So, what makes it fail? So, your goal in this course should not just be like to gain the ability to prove things. Your goal should be both to gain the ability to prove correct things and to gain the ability to fail to prove incorrect things. So those are equally important. Maybe the second one is actually more important. You want to develop your skill to the point that you are unable to fool yourself into proving wrong things. Okay, so let's start with proving a right thing. So let's start with proving this implication. So it is an implication, and so I should assume the left-hand side, the hypothesis, and try to prove the conclusion. So assume that there exists an X, a globally loved X. There exists an X such that all Ys love this X. Okay, now our goal is to prove this thing, right? So our goal then is to prove a universally quantified thing. So we're in a situation where we have an existentially quantified thing, and our goal is to prove a universally quantified thing. So looking back here, we are able to use an existentially quantified thing, so we will get to use existential instantiation. And we want to prove a universally quantified thing, so we will have to use the technique of universal generalization to carry out that proof. Okay, well I can focus on either one at first, but I'm going to choose to focus on the existential instantiation first. So this is how existential instantiation works. Me and the reader at this point, due to this assumption, we both agree, for the sake of this argument, that there exists something which is loved by everything. And so we can assign a name to that something. Let's call it X. We don't have to call it X, we can call it Z or whatever, but let's call it X. And the keyword I have been using here is get. Then we can get an X such that, and then such that whatever is inside here holds for that X. For all Y, y loves, and then I write whatever variable I chose to name that universally loved thing. And I have chosen x. I don't have to name it x, but it's a reasonable name since x was used up here. So now in my argument, I've given a name to that universally loved thing. And the subtlety here is I'm not allowed to use x here if it was previously used or if there were previous assumptions about x. But it wasn't. There were no x's previously. Okay, so now I've got this universal. And that just tells me, that everything loves x. So to make use of that, I would just apply it to particular cases, like take a particular thing, like this pen here, and I'd say, okay, then this pen loves x. Or me, I guess I love x. You must love x too. All of these things are true because everything loves x. But I don't have anything to apply it to yet, so I'm not going to use it. I mean, I guess I can apply it to x. It tells me that x loves itself, but that's not so helpful. Okay, so now let me focus on what I'm trying to prove. I am trying to prove this. So I will have to do this universal generalization type argument, which means consider an arbitrary y and then try to prove this thing in here for that y. So I am trying to prove that everything has something that it loves. The way to do that is to consider an arbitrary thing, y, and then prove for that y that there's something that y loves. So here's the universal generalization. Consider any y, and y has to not be previously used here, and it's not. So it is an arbitrary variable. Consider any y. Now, can I prove this? That y loves... can I prove this? That there's something that y loves? Well, to prove that there's something that y loves, I just need to find something that y loves. Okay, well, there's x. Everything loves x, right? So that's something that y loves. So since everything loves x, we have in particular, so this is universal instantiation, we have in particular that y loves x. So I hope you see the huge difference between this statement here and this statement here. This says everything loves x. This says y loves x, specifically y. And let's see. So my goal after I said consider any y was to prove that there's something that y loves. And how do I prove that there's something that y loves? I have to do this existential generalization thing, right? I'm proving an existential. So the way that works is find something that y loves. Well, I have done that. Y loves x. So, therefore, there is something that y loves. But that is what I needed to do to complete the universal generalization I started in this line. I said consider any y, and then the goal was to prove that there's something that y loves, and I have done that. So since y was arbitrary, so we have proven about an arbitrary y that there's something that y loves, we can now generalize to conclude. We may conclude that for all y, there exists x such that y loves x. Okay, and that's the proof. Let me stick my little box there. And that is the proof. So let me review this and go through where different quantifier rules were applied and which ones were applied. So the first rule we see after we assume that there's something that's loved by everything is where we assign a name to that something. So right there, that's where an existential instantiation, let me write it above. That is an existential instantiation. That's using the fact that we have this existential quantified statement to get this. Then, here, we start a universal generalization argument. So let me write UG for that. So here we start a universal generalization argument to try to prove that for all y, a certain thing is true about y. So consider any y, and then blah, 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 and then we finally prove that that thing is true about y. So this is where the universal generalization argument ends. And I guess down there is the conclusion that we got out of the universal generalization. So you see the universal generalization is this, takes up a lot of the proof, and other kinds of things can happen inside it. So inside the universal generalization, here we say, since everything loves x, we have in particular that y loves x. This is a universal instantiation, where we go from for all y, a certain thing is true about y, to applying it to a particular thing. We don't have to apply it to y specifically. We can apply it to anything, actually. But in this case, because of the way the variables are named, it makes sense to apply it to y. So here, this is a universal instantiation. And finally, over here, where we go from, well, we found an x which y loves, so therefore there exists an x which y loves. We found something that y loves, so therefore there exists something that y loves. Right here, that is existential generalization. We want to show that something exists that has a certain property, and so we found an example. All right, so in this proof, you can see sort of all 4 quantifier rules getting used. So this is quite a complicated example, and not all of the examples, not all of the derived rules are going to be this complicated, but this is one that I wanted to focus on in the video in detail with you, because it really has everything. So in the next video, so here everything went smoothly, right? In the next video, we'll look at what happens when we try to prove the other direction and why that doesn't work.